Let's talk about an incredible ability you use every single second of every day, and that is your brain's power to see into the future. Now, I'm not talking about crystal balls or anything like that. I'm talking about some serious neuroscience that explains how you can predict what's about to happen just moments before it does. You know, we all have this superpower, and you probably don't even realize you're using it. It's the reason a musician can hit a note at the perfect time, or how you can snatch a falling glass right out of the air before it shatters. Our brains are constantly, and I mean constantly, predicting what's coming next, just milliseconds ahead of time. So the big question is, how on earth does it do that?
Okay, think about this for a second. Picture a boxer in the ring. They're ducking and weaving, somehow avoiding a punch that's thrown in a tiny fraction of a second. How is that even possible? I mean, it seems like it should be faster than human reaction time, right?
And here's the mind-blowing answer. It's not just about having lightning-fast reflexes. The boxer's brain has already calculated where that punch is going to be, just based on tiny little cues and all their past experience. So they aren't actually reacting to the punch, they're reacting to their own brain's prediction of it. And that's the wild idea we're going to unpack right now.
So, how in the world do we crack this neural code? How does the brain pull off this amazing magic trick? Well, a team of neuroscientists in Germany just published a study that gives us a huge piece of the puzzle. And it turns out the answer is literally in our brainwaves. The most important thing to understand is this. Your brain is basically a master statistician. It's constantly running the numbers, calculating the probability of something happening at any given moment. So the more likely an event is to happen, the more your brain starts to prepare for it. And this isn't some vague gut feeling, it's a real, measurable process happening inside your head. And this is where it gets really cool. The brain actually uses specific electrical rhythms to represent this probability. The first one is called the alpha rhythm. As you can see, it's these brainwaves oscillating somewhere between 7 and 12 times a second. You can kind of think of this as the brain's internal metronome. It's setting the tempo for when it expects something to happen. But the alpha rhythm doesn't work alone. It's got a partner, the beta rhythm. And as you can see, this one's a lot faster, buzzing along between 15 and 30 times per second. These two rhythms, alpha and beta, working together, they form the actual neural signature of anticipation. In a way, it's the language the brain uses to talk to itself about what's coming next. And that brings us to the study's main finding. Matthias Grabenhorst, the first author, just sums it up perfectly right here. When something becomes predictable, these brainwaves, these neural oscillations, they literally get stronger. So there's a direct link between how much your brain believes something will happen and how much it physically prepares for it. And that's what lets you react so incredibly fast. So we've got the what, these alpha and beta waves. But what about the where? I mean, this amazing predictive stuff isn't just happening randomly all over the brain. The researchers were able to pinpoint a specific network of regions all working in concert to make these predictions.
So how did they actually see all of this happening? They used this really cool technology called magnetoencephalography, or MEG for short. It's a totally non-invasive way to map brain activity in real time. It does this by recording the super tiny magnetic fields that our neurons create when they fire. Just think of it like a super sensitive helmet that can listen in on your brain's private electrical conversations. It's this amazing tech that let them see exactly where and when those predictive waves were firing off.
And by using MEG, they found the absolute core of this prediction network. Now, it's made up of 3 key regions, and yeah, they have some pretty technical names: the posterior parietal cortex, the posterior middle temporal gyrus, and the sensory motor cortex. But hey, don't worry about memorizing the names. What's important is what they each do. Now, what's so cool is how these different parts work together like a team. The posterior parietal cortex, that's kind of like the timer. It's in charge of timing and getting the brain ready to move. Then you have the temporal gyrus, which is like the storyteller, processing the whole sequence of events over time. And finally, you've got the sensory motor cortex, which is the doer. That's the part that actually executes the movement. It's just this beautifully coordinated system for turning a prediction into an action. Okay, so this is all really fascinating brain science, but why should you care? What does this mean for us, really? Well, it turns out that understanding this predictive mechanism has some profound implications that go way beyond the lab and right into our daily lives. Seriously, the implications here are huge. This could totally change how we understand decision-making, or even how attention works. For athletes, it could lead to new ways to enhance performance. I mean, imagine training that boxer to literally read their own predictive brainwaves. And maybe most importantly, when these signals are disrupted, it could help explain some of the timing and reaction issues we see in conditions like ADHD and even Parkinson's disease. If we can understand the signals, maybe, just maybe, we can find new ways to treat them.
Which of course brings us to the future. So now that we've identified the signature and the source of our brain's predictive power, what do we do with that knowledge? Where does all of this research lead us next?
And this leads to the final, really thought-provoking question that the study's senior author posed. If these predictive rhythms are real, measurable things, happening in specific parts of the brain, could we learn to control them? Could we actually train our brains to become better predictors, to think even further ahead? This research suggests that possibility is really there, just waiting for us to explore it. What do you think?